So we have seen the rectangle. Now we are going to study about the partition of the rectangle. So uh, here is the definition. We cannot define directly the partition of rectangle, but we are going to take the stepwise definition. So first of all, say let P1 equal to A equal to x0, comma x1, comma x2 up to xn equal to b. So say this set is the partition of AB, and P2 say C equal to y0, y1, y2, yt equal to d. So consider this as a partition of CD. So what we have to consider is we have to consider P1 and P2 are the partition of AB and CD respectively. So now let us consider the partition P. Let us consider the partition P is equal to P1 cross P2. This is a set of all those two tuple xi, yj such that I is from 1 to n and j is from 1 to t. Then this set P is called a partition of the rectangle R. So this is the, you can say, cross product of xi, yj. So that is the two tuple of all those x and yj's. So this is the P is called a partition of the rectangle R. So this partitions divide the rectangle R into n into t sub rectangles Rij. So वो जो partition है P, P1 क्रॉस P2, तो वो क्या करता है, हमारा जो रेक्टेंगल है R, तो उसको n इंटू टी सब रेक्टेंगल्स में डिवाइड कर देता है, और वो सब रेक्टेंगल्स को कहते हैं आर आई जे. So which is given by xi minus 1 xi and cross yj minus 1 yj. So this can be given as a set of all those xy such that x is lies between xi minus 1 and xi, and y lies between yj minus 1 yj. So where I is from 1 to n and j is from 1 to t. So this is the sub rectangle. This is called as sub rectangle Rij. तो अभी देखिए हम एग्जैक्टली RIJ कैसे निकालते हैं. So let us see. So this is, say, we are going to first of all draw a rectangle, original rectangle R. So we know that we have seen just now that how to draw a rectangle, that is x equal to a and x equal to b and y equal to c and y equal to d. So this is your rectangle, and now I'm going to partition. So first of all, we have seen that P1 is the partition of AB. So we are going to partition the set AB, yeah, into n, you can say, sub intervals. You will get n sub intervals. So let us start. So this is your interval AB, and we are going to now partition something like this. So say A as x0, x1, x2. You can see that the orange lines, vertically lines. Okay, so these are the partition of AB, and xn equal to b, and so this one is the interval CD, and now we are going to partition this also. So this is y0 as C, y1, y2 and yt. So we have partitioned the CD into t subintervals. So partition of AB and partition of CD will result into sub-rectangles, and we can easily see that n sub-intervals from AB and T subintervals from, you can say, CD. So it will result into n into T subrectangles. So Rij is the subrectangle. You can say, you can consider any from out of this. So these are the subrectangles Rij. Okay. So and when you sum them, you will get the original rectangles. Okay. So this is all about partition of the rectangle. So now let us start with the upper and lower Riemann sum. Upper and lower Riemann sum देखते हैं अभी. तो देखते हैं what is the definition. So look at the definition. Let f is from ab cross cd to r, मतलब हमारा फंक्शन जो डिफाइन है वो रेक्टेंगल पे है, रेक्टेंगल ab cross cd to r be a bounded function of two variable x and y defined over the rectangle ab cross cd. Now, what you have to consider that partition of the rectangle. So let us consider P equal to P1 cross P2, where P1 is the partition of AB and P2 is the partition of CD. We know that, right? And dividing that AB cross CD into n into the subrectangles. We just now we have seen that, and that subrectangles will become like, we denote them as Rij. Rij is equal to xi minus 1 xi across yj minus 1 yj, where I is from 1 to n and j is from 1 to t. So first of all, let us we have to consider that Mij. So what is Mij? It is nothing but the infimum of the function over the subrectangles, and capital Mij, it is nothing but the supremum of the function over the again in the, you can say, subrectangle Rij, for I is from 1 to n and j is from 1 to t. So let delta of Rij, what is delta of Rij? It is nothing but the area of rectangle Rij, area of the subrectangle Rij. So it is given by, it is equal to xi minus 1 into yj minus yj minus 1. So this is nothing but the delta of Rij, that is area of subrectangle Rij. तो अभी हम डिफाइन करते हैं कि LPF and UPF. So what is that? So LPF is nothing but double summation, that is from I is from 1 to n and j is from 1 to t. Then look at this, Mij, small Mij and delta Rij. You can see that small Mij and delta Rij. So that is nothing but, now we know that what is delta Rij. Delta Rij की कीमत अभी हमने लिखी है, that is xi minus 1 and yj minus 1 yj. So अगर हमने वो delta Rij की जगह replace कर दिया, then what will we get? That is double summation Mij xi minus 1 into yj minus yj minus 1. So similarly, in the similar fashion, you will have to define UPF. UPF is defined by double summation I is from 1 to n, j is from 1 to t, capital Mij into delta Rij is equal to. Now again you have to replace this delta Rij in terms of xi minus 1 and yj minus yj minus 1. So we'll get something like this. So here we can see that LPF and UPF is defined. So what is that? So here you can say that LPF is called as lower Riemann sum. You can call it as lower sum also. And UPF is also called as upper Riemann sum of the function f, that is called, you can also say that it is upper sum of the function f. So this is the definition of upper and lower Riemann sum. So we are getting closer and closer to the actual definition of double integral. But हमने अभी देखा है कि हम किधर से स्टार्ट कर रहे थे और किधर हम जा रहे हैं. हमने स्टार्ट किया था पार्टी रेक्टेंगुलर रीजन से. देन हमने वो रेक्टेंगुलर रीजन को पार्टीशन किया एन इंटू टी सब रेक्टेंगल्स में. बाद में अभी हम डेफिनेशन देखी अपर एंड लोअर रिमन सम की. अभी हम आगे जाते हैं. सो लेट अस कंटिन्यू विद द सम रिमार्क. सो देखिए हमें क्या मिल रहा है रिमार्क में. सो डबल समेशन डेल्टा आर आई जे, डबल समेशन डेल्टा आर आई जे की वैल्यू क्या आ रही है. सो व्हाट इज दैट डबल समेशन डेल्टा आर आई जे. हाँ, सो डेल्टा आर आई जे वी नो दैट डेल्टा आर आई जे की वैल्यू xi minus 1 and yj minus 1 है. So what you have to do is you just slide this one, that j is from 1 to t to yj minus 1. Okay, and what you have to do is you have to solve it. That means you have to take the sum over the j is from 1 to t. Yeah, so what you have to do is you have to just put the value j is equal to 1 and plus j is equal to 2 and so on. So you will get, when you put j equal to 1, you will get y1 minus y0. Then sum is there, so you have to take plus sign, and then y2 I will be sorry j will be become 2. So it will be y2 minus y1, and similarly y3 minus y2, and so on. You will get last term as it is. You can see that it is t. So yt minus 1. So when you solve it, you can see that here it is y1 plus y1, and here it is minus 1. It can be cancelled. So again here it is plus y2, and here will be minus y2. It will be cancelled, and so on. So up to plus yt minus 1 and minus yt1 will be cancelled. So remaining terms is yt plus yt and minus y0, plus yt and minus y0. Here you can see that. And similarly, yt means d, you know that, and y0 means c, right? So similar way, in the similar fashion, summation I is from 1 to n xi minus xi minus 1 will be I will tell you that it is nothing but xn minus x0. In the similar fashion you have to solve it. हमें ये जैसे हमें सॉल्व किया है समेशन j is from 1 to t yj minus 1, वैसे ही हमें समेशन I is from 1 to n xi minus x 1 सॉल्व करना है। तो आप भी जान सकते हैं कि हमें xn minus xn x0 ऐसे ही मिलेगा, and we know that xn means b and x0 means a, so d minus c into b minus a, and this is nothing but the area of rectangle AB cross CD, your total area of whole that original rectangle AB cross CD. So here is the remark. You just have to take the you just remember this. Okay. So let us continue with the theorem. So this is the very simple theorem, but it is very important one. So let us have this statement of this theorem. Let R, that is equal to AB cross CD, be a rectangle. Let F be bounded function defined on R. Let P be any partition of R. Let Mij, we know that what is Mij? It is the infimum of the function in the subrectangle. And capital Mij is also a supremum of the function in the subrectangle. Then what do we get? The result as m small m b minus a d minus c less than or equal to LPF, less than or equal to UPF, and less than or equal to capital M b minus a d minus c. Now this result is very important. Uh, so we are going to prove it. So let us start the proof. Let P equal to P1 cross P2, where we know that as usual we have seen that P1 is the partition of AB and P2 is the partition of CD, dividing that as a original rectangle into n to the subrectangle that is called as Rij. Rij, we know that it is xi minus 1 xi cross yj minus 1 yj, and from I is from 1 to n and j is from 1 to t. Okay, so now let us consider it is given in the statement of the theorem, that is Mij. What is Mij? That is the infimum of the function in the subrectangle, and capital Mij is nothing but the supremum of the function in the you can say Rij, that is on subrectangle. I is from 1 to n and j is from 1 to t. Now see what is clearly mentioned, that m less than or equal to Mij, less than or equal to capital Mij, less than or equal to m. अभी आप कहेंगे कि what is m and what is capital M. So it is nothing but infimum of the function in the rectangle, in the whole rectangle. जो भी आपका infimum है वो है small m, ठीक है, and capital M means supremum of the function in the rectangle. ओके, जो भी आपका सुप्रीमम है रेक्टेंगल के लिए, तो वो डिनोट करते हैं हम एम से, कैपिटल एम से. सो द let us continue with this in equation m less than equal to mij less than equal to capital Mij less than equal to m. अभी आप देख सकते हैं कि small m will be less than equal to Mij and small Mij will be less than equal to capital Mij, and it is less than equal to capital M, because if you see if you look at the diagram of rectangle and when you partition it, okay, then you will come to know that आप समझ सकते हैं कि अगर आपने कंसिडर किया और रेक्टेंगल और उसको पार्टीशन करके सब रेक्टेंगल मिल गए, तो कौन सा भी आप सब रेक्टेंगल चूज करो, तो फॉर दैट सब रेक्टेंगल यू विल गेट स्मॉल एम। स्मॉल एम मीन्स आपको पता है, अभी हमने डिफाइन किया कि इट इज नथिंग बट द इन्फिमम ऑफ द फंक्शन फॉर द रेक्टेंगल, वोल रेक्टेंगल। तो अभी आप समझ सकते हैं कि इट विल बी इट विल बी वेरी लेस क्वांटिटी, और यू कैन से वो सबसे छोटा ही होगा, स्मॉल एम विल बी छोटा ही होगा। और उसके बाद जब आप कौन से भी सब रेक्टेंगल कंसिडर करोगे और आप उनका एम आई जे निकालोगे, मतलब इन्फिमम निकालोगे, तो वो स्मॉल एम से बड़ा ही आएगा, बड़ा या फिर इक्वल आएगा, बट दैट विल बी ग्रेटर देन दैट स्मॉल एम। ओके, वो उससे छोटा नहीं होगा। एंड बाद में आपको पता है वो तो इट इज़ वेरी सिंपल रिजल्ट दैट एम आई जे एंड कैपिटल एम आई जे, ओके, उनके बारे में, दैट इज स्मॉल एम आई जे इज ऑलवेज लेस देन इक्वल टू कैपिटल एम आई जे, दैट इज you can say it is there, right? And capital Mij will be less than or equal to capital M, because if you consider any sub rectangle and if you calculate capital Mij, it will be lesser or maybe equal but not greater than that M, because जो M है, कैपिटल M है, वो सुप्रीमम ऑफ द फंक्शन है और वो भी रेक्टेंगल का है, तो रेक्टेंगल का सुप्रीमम विल बी ग्रेटर, ऑलवेज ग्रेटर। So that m less than or equal to small mij less than or equal to capital Mij and less than or equal to capital M will be clear to you. So now अभी आपको क्या करना है, तो अभी ये जो चार टर्म है उन सबको yj माइनस वन से मल्टीप्लाई करना है, so you will get this you can say step, okay, then you have to take the summation of j is from 1 to t over it, okay. Now what you will get it, uh, नाउ व्हाट यू विल गेट इज, ये जो आप देख सकते हैं कि इस इनइक्वालिटी में स्मॉल एम है, स्मॉल एम इज यू कैन से इट इज नथिंग बट वन कांस्टेंट यू कैन टेक आउटसाइड ऑफ द summation, and you will get summation yj minus 1 over here, okay. But over here in this second inequality, you can say second term, here it is small mij, ij is there, so suffix is there, so you cannot take it out from this summation। और उसके बाद समेशन जे इज फ्रॉम 1 टू टी, कैपिटल एम आई जे, इसको भी आप सफिक्स है तो आप उसको समेशन के बाहर नहीं निकाल सकते, बट लेस देन इक्वल टू समेशन कैपिटल एम है, सो इट इज इधर आपको सफिक्स नहीं दिख रहा है तो आप उसको समेशन के बाहर ले सकते हैं, इट इज नथिंग बट द कांस्टेंट एंड समेशन जे इज फ्रॉम 1 टू टी वाई जे माइनस वन। सो अभी जस्ट नाउ हमने रिमार्क में अभी हमने सॉल्व किया कि समेशन जे इज फ्रॉम 1 टू टी वाई जे माइनस वन का आंसर आता है वाई टी माइनस वाई जीरो, अभी हमने सॉल्व किया था। सो वाई टी माइनस वाई जीरो, एंड ये जैसे है सेकंड एंड थर्ड टर्म जो है जैसे आप लिख सकते हैं, एंड कैपिटल एम वाई टी माइनस वाई जीरो। नाउ यू नो दैट वाई टी मीन्स डी एंड वाई जीरो मीन्स सी, so and less than or equal to this is the same thing। Now md minus c, now what you have to do is you have to multiply whole thing again, now you have to multiply whole thing, take the summation xi minus 1, okay, in the whole you can say terms, okay, so you will get this one, this whole term, okay, the big term। Now we can see that summation I is from 1 to n xi minus 1 is, अभी जस्ट हमने सॉल्व किया था रिमार्क में कि उसका आंसर आता है एक्स टी माइनस सॉरी एक्स एन माइनस एक्स जीरो, तो एक्स एन माइनस एक्स जीरो का मतलब क्या है, तो ए बी माइनस ए होता है। बट ये जो अभी हमें मिला है ये दोनों के बीच में, तो इट इज़ नथिंग बट डबल समेशन एम आई जे एक्स आई माइनस वन इंटू वाई जे माइनस वन। तो स्मॉल एम आई जे के लिए ये है आपका एल पी एफ, दिस इज द डेफिनेशन ऑफ एल पी एफ, and less than or equal to double summation capital Image xi minus xi minus 1 yj minus yj minus 1. It is nothing but the definition of UPF, upper Riemann sum. This is the definition of lower Riemann sum, and ये जो है आपका उसका आंसर आपने सॉल्व किया है. So this is nothing but m d minus c b minus a less than or equal to LPF less than or equal to UPF and less than or equal to capital M d minus c b minus a. So we have proved this theorem. So it is actually very easy to verify this theorem, but it is also a very important theorem. So we will continue in the next lecture